not forget agriculture. Please do recognize what are crops. Many of the people at the seedling stage do not know what is the bajra plant and what is the jawar plant. And that's why I think your knowledge, which is very important basically, is to recognize first agriculture. And then you know how did the plant grows, how the crop grows, what are the losses, and then how do it need the treatment. I think that is one thing. The second thing is that we have actually, as a pathologist, we have done a wonderful job. I would like to particularly tell Honorable Vice Chancellor Sir, the biggest contribution of plant pathologists in this country is wiping out some of those diseases which threaten crops. During Green Revolution, wheat rust is a major issue. When I used to teach my students, when as a student, I used to get every day the best sample was of wheat rust. And I used to show. Today, I am not able to get a single sample of wheat rust. And it was so devastating disease that in 1945, I think if the history says we have almost lost 10,000 people because of shortage of wheat to them in Madhya Pradesh. Similarly, you all know about Bengal famine. Bengal famine of rice was basically due to a disease called as Helminthosporium. Every pathologist learns it in history. Today you do not get a sample of that disease because we have perfectly managed it. So these are what we call it as success stories. Over a period of time, during the Green Revolution, we have made certain substantial genetic improvements in our croplands, which has given our 50 million tons of food production during the year 1947. Today we have reached 270 million tons and matched the population growth rate better. Population growth rate was sometime 2.8, 2.5, 2.3 and it has come down to now less than 2. But our food production rate has always been able to match, and that's why we are able to have sufficient food. Probably you must have seen that there has been a problem of storage of food now, and post-harvest losses are more great. So this is now another issue that as a pathologist, what is the next that we have? Because as I said, that this is sufficient, but it is not going to be a permanent feature, because once grown in wheat, it cannot be survived for 10 years. You may be putting it in silos for some time, but it doesn't mean that it can remain. Otherwise, again, a situation will come, what we call it as ship to mouth, as it has happened during 1960s. And we introduced several of these new cultivars and changed the entire scenario of this country. Now, therefore, after now this Green Revolution, what is the next for pathologists to be done? That is very important. Now we are talking about what we call it the gene revolution. The earlier was only what we had basically was a variety development with normal crossbreeding program. But now we are talking about real gene revolutions, where we are now trying to put genes which will be useful for a certain traits. Climate change, how do we mitigate climate change? How do we produce varieties or hybrids or cultivars which will resist the climate change? For example, in wheat, I think you are all knowing Punjab. Any 4 degrees temperature reduction during flowering can reduce our production by 25%. This is known. Now, if this high temperature is going to be global, phenomenon and going to be changed, as he has very rightly said, that the Arctic will be used for navigation, then what will happen to our temperature during February, March, April, when our grain filling of wheat is occurring? Remember, therefore, you will have to grow varieties or develop varieties which will resist that change, and still there will be grain filling. Otherwise, there is going to be a serious problem, because Punjab is the granary of this nation. It is very important. So now in future, we will have to look into more kind of interactions of climate change, temperature, maybe humidity, maybe other thing, along with your pathogens and this, abiotic and biotic stresses together. And this gene management is going to be important. Now it's not going to be very easy. Probably you must be reading everyday paper. For GM mustard, there are demonstrations going on. We are trying to use a GM technology for developing what we call it as a simple hybrids in mustard. Because those in normal process, those mustard you don't get smell sterility. What Deepak Patel has done is only put it in a gene where you can have male sterility and produce hybrid which will yield better. Now, there is a resistance because there is a resistance overall to genetically modified crops, or what we call it as biotic crops. Now, in this situation, BT cotton already 15 years, we survived perfectly okay. But now what next? There are viral diseases like you have in Punjab, what we call it as the leaf curl of cotton. Last year, Punjab suffered heavily because of whitefly and this leaf curl virus. I surveyed the entire area from Ludhiana to Ganganagar. I know because I was the major cotton, I was appointed by government to look into this thing. And I was surprised that there is absolutely no, because we have several kinds of hybrids highly susceptible to them. Now, can we have gene technology? Viruses cannot be controlled by your sprays, cannot be controlled by seed treatment, it cannot be controlled. So you have to use now these new technologies to really develop and convince. So in future, when you develop technologies now, they should be socially acceptable also. This is another issue which is coming. So society has now become very aware. They would like to say that I don't want to eat a food produced out of cottonseed oil because it contains certain toxin according to them. Although we have all safety regulations and everything, but still they are not convinced. So these some issues, therefore we have to. So our research earlier in Green Revolution period, nobody questioned us that what are you doing in labs. Today the society is questioning us that what you do in the labs and you feel, tell us. So therefore it is very important to really convince. So science we'll have to really think in different terms. Science has to be communicated also to know properly. So we need to have scientists who can communicate properly. Otherwise, as I often say, that if I cannot tell my farmers what I do in the name of science, it is worth not doing it. Because if I go on telling that this is what is gene, this is what is relation, what is replication, I can tell him so many things in biotechnology or genetic engineering. But he doesn't need that. What he needs is how to manage that thing. That's why it is very important that what we have to, how society has to be convinced, how society has to be told. And this is the major issue which you are, I think, encountering every day today in terms of all NGOs, many society associations, even politicians need to be told what is to be done. So if we are, our direction in plant disease management has to be changed. We can do research, but at the same time it is to be applicable. Naturally, we'll have to convince all those who are involved around it. So this is a new phenomenon in this 21st century. Kindly see that whatever now we are doing for climate change or management of diseases or studies, I think they have repercussions if we have to use these technologies directly in the field. So with these few words, I would like to really thank the organizers. Yesterday she phoned me that you have to be chief guest. I am thankful to her that because I have actually a professional lecture to be given after this first